analysis we do after the fact, but what I'm going to talk to you today about is maps. So, in the past, vehicle autonomy has taken two approaches. On the left side here, you're seeing one of the challengers from the DARPA Grand Challenge, in which vehicles had to race autonomously through the desert. They had absolutely no infrastructure to work with, not even pavement. On the other side, you see the National Automated Highway System, which is actually earlier than the DARPA challenges, in which they buried magnets in the road, and vehicles used those to navigate and follow within the lanes. Given the state of the technology at the time, both of these approaches made some sense. But it's not the approach we've been taking, and it doesn't sound like it's the approach that a lot of these other groups that have spoken today are taking. Instead of requiring additional infrastructure or assuming that there's no infrastructure at all, we split the difference and use a virtual infrastructure in the form of a digital map. Now for us, a digital map could mean a lot of different things, and what I want to do today is really get down to the details of what a map is for us. Because a lot of people hear that the Google self-driving car uses maps, and it's not always clear what exactly that means. A map to us is any sort of geographic information we can tell the car about in advance. It could be obvious things like where a lane is, or the fact that there's a stop sign. But it can also be invisible things, such as an implied speed limit or an implied crosswalk. So what you see here is an elevation view of an intersection near our campus. And we really have, similar to you guys, a very detailed 3D representation of the world which the cars use to navigate. And here you see this box on the left represent where the GPS we think we are, and the car represents where we think we are according to our map. As you can see, if we had been driving where the GPS told us we were, we would have been in a lot of trouble in this situation. And one misconception I wanted to clear up while we're looking at this is that we can look at that and say, oh, the GPS was wrong and our localization of the map was right. And that's not exactly true. The important thing is that we're consistent. We are not giving a position in latitude and longitude that's necessarily metrically accurate to the perfect degree. Instead, we're giving the car a consistent answer and telling it, according to the map you have, this is where you should drive. If another company came up with their own digital map that said the lane was 1 meter to the left, everything would be fine as long as you're consistent. And in fact, in the past, due to a small bug, we had built all of our maps a couple of meters off of sea level in terms of elevation. And it turned out not to be a big deal. Because again, what we're going for is a local consistency, not metric accuracy. On top of that graphical map, we built a logical map, very similar to you guys, it seems. And what you see here is a fully completed intersection representing every crosswalk, every approach into an intersection, all of the driveways, in fact, as well as which lanes are controlled by which traffic signals. This is built using a semi-automated process by my operations team. Now, besides the vehicle that we recently announced, which I don't have anything to tell you about today, one of the other announcements we've made this year is our refocus on surface street driving. I wanted to give you a little bit of context about what that change has looked like for us. What you see here is an overview of Google Maps. Look at 280, which is a very nice interstate on the other side of the mountains here. When people talk about enjoying driving, this is the sort of freeway that they're talking about. It's nice, gentle curves, which you can see in that picture there, lots of lush greenery. It's a really nice place to drive. What you see here is Google Maps' view of this. One misconception about our project is that we are using Google Maps. In fact, it's a separate team. We've built our own maps. We talk with the team working on Google Maps, and we're heavily inspired by their work, but these are very different sets of digital maps. So this is Google Maps' view of this area of 280. This is our view of the same area. As you can see, there's a lot more detail going on here. We had the exact positions of the lane centers as well as the boundaries and the types of boundaries so that we know that we're not allowed to cross that yellow line there, but there are striped lines which allow lane to change between them. Now, there's a lot going on here, and yet there's a lot of redundancy. Each of these is really a cookie-cutter lane next to each other. And the only really interesting thing going on here is the on-ramp lane that you can see dashed in the top portion of the image. Now, earlier I had talked about how we didn't want to add additional infrastructure, such as burying magnets in the road. But that doesn't mean that we don't use any physical infrastructure at all. In fact, we do a lot. What you see here is a freeway designed for high-speed driving. Now, the reason many of the projects, including our own, started with a big focus on freeway driving is because the roads were built so that we could move and humans could navigate at 65 miles per hour. There is a lot of infrastructure work that went into this, and we're very grateful for all the work that's going here's Google Maps' view of the surface street near Mountain View. You can see just from this picture that there's a lot more going on. There's a very bizarre intersection. You can see a stop sign out in the distance. There are crosswalks you can just barely make out. But clearly this is more complicated than the freeway scene we just saw. And this is what our view of that same area looks like. Oh, I see a lot of cameras going on. You can see a tremendous amount of information here. We've represented the driveways, the exact merge points between lanes. There's a very bizarre pattern of crosswalks going on there. And each feature that we've added here was added for a reason. As we negotiate between the map building and the actual driving software teams, each of these has been added for a reason to make the car able to navigate these fairly hairy situations. If I had shown you the same intersection 2 or 3 years ago on our project, it would have been much simpler. But we found the additional information really does make the driving problem simpler. Now, having built these maps, the problem then becomes keeping track of what's going on. Sadly, after we finish our job, people then go and mess with the roads again. It's a very necessary task. And an important point is that we want the cars to be robust to changes in the world. So what you see here is the car noticing that there's a construction crew out. It's identifying the pattern of cones and driving around the construction area. So a fundamental point in how we're approaching maps is that they make the driving task easier, but you can't rely on them 100% of the time because we know that the world changes. One way that we have been able to keep track of the work that's going on is by keeping track of Caltrans' work. We had a very fortuitous meeting with Caltrans several years ago where they mentioned that they have a system that tells us where all the lanes are closed. This is incredibly useful information if what you've done is build a map of all Caltrans roads and you want to keep track of where they're going and where they put cones down and where you might need to go back and remap your world. This has been a great data source for us, and we're really hoping that other transportation agencies will be able to produce something similar. When I've given talks like this in the past, I'm often approached by local DOT operatives from different states or municipalities who say, we've got you covered, we have this database of construction projects going on, please just use that. The problem is, if you're approached by 200 different people who all have their own data formats, you've got a really serious problem. So I think a big challenge from the transportation world is going to be standardizing this information, not just for our project and not just for autonomous vehicles even, but for other projects that are building their own digital maps for automated driving or simply to route people around as they're driving manually. So I think this is a really big challenge in terms of the infrastructure in the future, and I hope that you'll all be able to help us out. Thank you.